Hey there, this is part two. Go back and see part one if you haven't started with that. We were initially looking at this brain playback. Now, this is a patch that's on eCampus. I might send you the modified version that I've just made for this one. This is the thing I was doing right at the end of class that we didn't really get to see it fully play out, but I wanted to show you some examples of how you can work with in more detail with this brain playback. So think of the first one as the intro. This one is much more the kind of thing that I'm hoping you'll do for your project. It's not that you want to work with this filter graph or you have to do anything. This is just one way of working in a more advanced way. So what I've got here is our low beta. It's being mapped to a range of frequencies. What we're going to be doing here is introducing three new kind of objects or ways of working with MSP. Whenever you see that tilde, it means you're in MSP. And so instead of sending this straight to that keyboard, that K slider like we've done before, and use MIDI, we're going to use a different approach to synthesis that I think you'll find interesting. And but it's just really an example of how you can use this same data and work with it in many ways. It's like that same idea from Lev Manovich, that modularity of working with digital media, how you can take these streams of data and kind of put it towards into a different patch and have a totally different effect, but use the same kind of information can take many different forms. And so this time what I'm going to do is, instead of having this low beta control a specific pitch like a MIDI note, C, middle C or something, I'm going to have it control a filter, an equalization. You know, on your car stereo, when you increase the bass or the treble, that's what we're going to be working with here. And so that's the filter graph. So I just opened up a filter graph help file, and this is exactly the help file with some little modifications in it. So this is the kind of style of things that I want you to do for your final project. This here is the filter graph, and this spectrum here is low frequencies and high frequencies. Remember when we were playing with testing your hearing? Those sounds in the high frequencies would be up here, the low ones are down here, and this is how loud it is. And so there's many different ways of working with a not a graphic equalizer, this equalizer. And so right now I'm working with a high pass filter. It says anything above this frequency, let's lower that, we're going to hear anything below it. Kill that. Don't play anything lower than this point. So you're not going to hear anything that's lower than this area is not being heard. And so what this Q does is it controls that. Do you see how spiky that graph gets when this gets increased, and how more slowly, it's like a slow kind of curve there with the Q. So you can kind of set it up spiky at different angles. Now the key ones to work with, if you're just kind of getting used to equalization and filtering, is the high pass that says let certain notes, in the low pass, high notes will pass, the low pass says only the low notes pass. So it's the same thing in reverse, and you can control, okay, how high up that goes. Okay, another kind of key things are the peak notch. This is something that you really want to use when you're working with trying to remove certain, there we go. If you're trying to remove or boost certain frequencies, let's say you have a hum that you want to get rid of, you can go like that, and it's at like 60 hertz, let's say. That's a common electrical outlet kind of thing. You could just dial that up to 60, 60, boom. And now that will kind of get rid of it. And this Q, once again, is kind of how, is it just that little sliver, or is it a wider kind of berth of the tonal range of the frequencies around this? What's the kind of slope of working with the frequencies around that? Okay, and but we're not going to work with peak notch so much. Display, think of that as like this all pass is just like normal. Okay, we're going to set it to high pass. Okay, And what we're going to do is we're going to map this information from from the low beta. I've said this is like hertz, from 110 hertz to 15,000 hertz. We're going to send that to this filter. And so this is just receiving it. And this is the thing that didn't work last night, is I accidentally sent the thing for the tempo, which we're going to talk about in a second, to this instead. So this totally works. Don't worry about that set thing. What that set thing is doing, all these guys, is just when I lock this, it's allowing it to see those changes there from my physical hand moving this information, and that's what those set things are doing. But really, you can just kind of move it straight through from this number, and we're going to be doing that. Our brainwave data is going to be telling this what frequencies to let pass. Okay. Now, so that's what the EQ is doing. That's the equalization, the filter graph. That filter graph runs into this biquad object. So the way that this works is you put any kind of sound into this, and then the filter graph runs into that, and that's what's being so these kind of work in combination, and this filters whatever runs into that. So you could go with put an SF play in here that plays a sound file. So this little object up here, this part of the it's part of the help file. You can choose a sound file, and it gives you a bunch of different sound files. You can choose your own kind of sound file. Maybe you make a recording of yourself humming, and then the hum, you can play it like really slow, and then it's EQ'd according to your brainwaves. An interesting kind of idea for a self-portrait, right? So you could do something like that. You could slow that down with the grain stretch, and then feed the grain stretch right into here as well. This is that cool object that lets you stretch things at ridiculous amounts of speeds. Take these kind of feeds right here, bring them right into the biquad, and then you'll filter that. What I'm going to do right here is use something we haven't talked about yet, which is we can use these oscillators, which are the sine wave, the ramps, triangles, and things like that, and for you to kind of play with. Maybe we'll listen to those in a second. So here I'm going to just use the noise. You can also just do it directly on your audio input. You can hear me saying things now. In fact, it might be kind of funny just to hear that. Okay, maybe I'll EQ. Let's have the brainwave data EQ this. So I'm just going to start this up. Testing 1 2 3, testing 1 2 1 1 2 3 1 2. You can see this going here. I'm going to set this over to dry, and let's see. Let's just test it with the noise. There we go. So this is the noise one. It's just totally what we call white noise. I'm going to just let you hear what that sounds like. If you just fed this directly in and avoided all the stuff that's going on here, it's just a wash of noise. Okay? That's what we're processing, just that sound alone. Now, so what are we doing? We're taking that sound and we're filtering it, okay? Putting these different, only letting certain frequencies of that white noise pass, okay? And that's being generated by this, the information coming from your brain waves. Okay, so your brain waves are filtering the noise. I thought there's something about brain and noise that's kind of good. Another key aspect of this is, instead of it just being this one wash of sound, when we listen to this, it's a sound that doesn't end. It's just, there's no stop, beginning, middle, or end. It's not like a note to it. So what I've done here is this function graph we've used many times this semester, and you can type in, this is like 2000, and it's going to be like and so this is the amplitude, how loud something is. So it starts at 0, and then it goes gradually up, and then it fades out, and then you could see here this 2 beat. Okay, here's the duration. So what we have here is, this is the next part of what we've done. I have the tempo. I've taken the high beta and I've mapped that to this kind of tempo range between a very short kind of duration to a kind of 2-second long duration. And I'm sending the high beta information to this metro. So that's kind of controlling the note durations. And then I'm sending that note duration straight over to our friend here. So that's governing how long this note's going to be. Our high beta wave is controlling the duration of the notes. Very cool. So now what I want you to see is that you can start using either the same or other variations of your high alpha, low alpha to start to control other aspects of the sound or the visuals. Okay? So this one here is just taking the beat from the metro every time it sends out a bang. Let's say in this case it's going to be 359 every 359 milliseconds. That is going to be going over to this little guy here, and that establishes our beat. Okay, so if this goes 370, I'm going to hit that. You'll see over here 370's there, and now it's going to be a much shorter note. Okay, we'll just so you can hear this, I changed this. Let's hear what that sounds like. Cool. Okay, so let's just listen to this combination of things. Okay, stopped it for a second. It's kind of cool. It's getting interesting. The thing that makes this interesting, much better than if this was just pounding out every 2 seconds or every 250 milliseconds, this kind of consistent beat, is this mapping of the brainwave data. So it's giving us, one of the things that we like about, or I like about working with digital media is, and especially this generative media than Max, is that this thing can fluctuate. It's more organic, more human. Remember, those are the kind of things that we like about working in this digital medium, is that you can make things that reflect more organic nature. And so this creates a kind of more a humanness if we start to map our brainwave data instead of just pounding out this kind of robotic beat here. Okay, so that's why that's kind of sounding good. And now last little thing, I'm sending it for a little bit of fun. I'm setting up some delays for us to kind of just add some sonic interest. And one little trick that I'm doing here is I'm taking this duration, how long the note is, and I'm feeding it into how long our delays are going to be. So there's some kind of, as this changes, our delay times are going to change. Right now it'll cut this left one in half and this right one into a quarter. And so whatever, it doesn't matter, whatever this, let's say this is 300, boom, this information is now 150 and 75. So it's responding to whatever duration comes in here. We're messing with the delay. So let's hear what that sounds like. And I've set up this wet dry parameter, and what that allows you to do is to say how much of the delay do you want, and the term wet is all the delay, none of the straight signal, and this is halfway, half of this and half of that. Let's hear what that sounds like. Let's go full dry, and then I'll bring in the delay. So this is the dry signal. Okay, and you can kind of make a balance of that. I'm going to bring it up so you can hear it more. Okay, I'm going to pause that. Now, there's a couple important parameters when you're working with delays. The first one that we've seen is how long the delay time is, and you could change this to be something like 0.33, and then this could be like 0.66, or it could be, I wouldn't do it at 1. But that would equal whatever the duration is. That could be okay too. We could try that and see what happens. This is the key one here. This is called feedback, and it's kind of preset to a ridiculously high level of 0.96. You don't want to get higher than that because it's going to start to kind of combust and blow, what they call it, blowing up. So you don't want this to be 1 or else it blows up. So this 0.2 is a small amount. This 0.5 is much more. Let's increase this to 0.9 so you can hear what that sounds like. And you can make presets for all this if you start to get a thing that you like. And let's so it's really like that dubby Jamaican. If you guys listen to a lot of reggae, you can get that's what they're messing with these. You can have one that's very little and one with a lot. That's kind of cool. Listen to this in headphones. I think you'll really dig it. This one's maybe too long. Let's bring that down to like 0.66. You can hear as this becomes shorter, it gets that kind of like electronic. I'll put it on both of them. Very like metallic-y kind of sound. Let's bring this down to like 0.5. I almost blew it up there. Okay, so you get the idea. So here we're using these, the kind of filtering is based on the low beta, the tempo is based on the high beta, and then we're incorporating a combination of the filter graph, the whatchamacallit here, I'm forgetting the name right now, the function graph, and the delays to kind of make the sound really much more interesting. And you could put any kind of sound file in here. Let's just use one of their cellos. Okay, let's try that. And hit play. We got to say loop. Now we can't hear it so good. Okay, so you could also, let's listen to it with an oscillator. There's that delay. Okay, so I'm going to stop that. This is the end of the tutorial, and email me if you have any questions, and hopefully just get creative. And this is just one way that you can work, but I just wanted you to see a more advanced example of how to work with this kind of brainwave data, and I'll see you next week.